Welcome to The Explainer. Today, we are diving into a blueprint for the future. And I mean that literally. We're going to look at how artificial intelligence is completely changing the way we design and build our physical world. You know, the buildings we live in, the infrastructure we use every single day. So right off the bat, let's get one thing straight, because it's the most important idea here. This is not about robots taking over jobs. It's about AI becoming an incredibly powerful new tool, a superpower really, for today's architects, engineers, and builders, letting them do things that were basically impossible just a few years ago.
Okay, let's get into it. Here's the blueprint for our explainer today. We're going to look at the huge shift from documents to data, then jump into how AI is changing design, engineering, and the construction site itself. Then we'll tie it all together with the one thing that makes it all possible.
First up, let's talk about the massive change happening at the very core of the architecture, engineering, and construction world. And really, this isn't just some small update, it's a whole new way of thinking. And this slide just nails the core of that change. For decades, the industry has worked in these separate bubbles, right? An architect makes a drawing, hands it off to an engineer, who then hands that off to a contractor. It's a one-way street of static documents. But the new way? It's a continuous, data-driven flow where live information is shared between everyone at every stage. That means smarter, faster decisions for the whole team.
So let's see how this whole data-driven thing actually plays out in our first big area, design. We're not just talking about AI making cool-looking shapes anymore. We're talking about a leap into something way more powerful. This is the key. You see, generative design gave us options, which was cool. But predictive design, it tells us which of those options will actually work best out there in the real world. It's like having a crystal ball that can forecast a building's performance, structurally, financially, environmentally, before a single brick is laid.
So this new workflow is really where it gets interesting. The AI acts like a co-pilot. It can explore thousands of different design ideas in the blink of an eye, predict how each one will perform, and then serve up the very best options. And then the human designer steps in, using their creativity and expertise to choose and perfect the final design. It's a true collaboration.
And this isn't some far-off theory. I mean, just imagine you're designing a huge skyscraper. The AI can show you instantly how changing the look of the outside wall affects its carbon footprint, its energy bills, and even flag if it's going to cause a construction nightmare down the road. It learns from thousands of past projects to give you that kind of foresight. It's incredible.
And if you think that's wild, check out what's coming next, AI agents. Think of these as systems where you can give it a complex problem, like design a sustainable 3-bedroom house on this specific piece of land, and it can go off and run all the different software by itself to come up with complete proposals. Okay, so a brilliant design is amazing, but it's totally useless if it can't be built safely and efficiently, right? And that brings us to our second huge shift, how AI is grounding all this creative vision in the hard reality of engineering.
This is essentially the birth of a new discipline, data-centric engineering. For years, engineering has relied on expert human judgment and well-known standards. This new approach adds a third pillar, using high-quality data from countless projects as a core source of intelligence, supercharging that human expertise. Now, it's really important to get this, it's not magic. It needs a solid foundation to work. You've got to have clean digital models, things like BIM, that's Building Information Modeling, plus verified libraries of materials and parts. And critically, you need feedback loops so the system learns from what actually happens during construction and even years after a building is being used. Suddenly, data from old projects isn't just something you archive, it becomes one of your most valuable assets.
And just think about the wider implications for society here. An AI with access to every inspection record for every bridge in an entire country could spot hidden patterns of wear and tear. It could tell us which bridges need maintenance before they become dangerous. And even better, it helps engineers learn from all that data to design the next bridge to be safer and last way, way longer.
All right, let's go from the digital world to the physical one. It's time to see how all this incredible digital intelligence actually turns into physical stuff out on the construction site.
And listen, this is not science fiction. These AI-powered tools are on job sites today all over the world. We're talking about robots that can mark out building layouts with perfect precision, drones that track progress from the sky, and even computer vision systems that act as a safety watchdog. And the impact is huge. It helps with labor shortages for sure, but more importantly, it takes people out of harm's way, making the whole industry safer for everyone.
You can see the clear evolutionary path we're on here. Right now, it's about robots handling very specific, supervised jobs. In the near future, we'll see teams of humans and machines working side by side. And eventually, whole complex jobs like moving all the Earth on a site could become almost fully autonomous, all guided by AI.
Of course, getting to that fully autonomous future isn't exactly a walk in the park. There are some serious, real-world challenges to solve. I mean, how do you make a robot know its exact location down to the millimeter on a muddy, chaotic construction site? How do you make sure the digital plan and the physical reality are always perfectly in sync? These are the tough nuts that engineers are cracking right now.
So we've seen how AI is totally transforming design, engineering, and construction. But as we look across all these amazing advances, there is one single powerful thread that connects every single one of them.
And this table just sums it up perfectly. The roles aren't being replaced, they're being amplified. Designers get that co-pilot that can see into the future. Engineers get a data expert to back up their decisions. And contractors get smart systems that help them build safer and faster.
And that brings us to it, the single most important takeaway from all of this. It's this simple but profound principle. Whether you're talking about predictive design, data-centric engineering, or autonomous robots, none of it works without clean, structured, high-quality data. Data is the foundation that this entire new world is being built on.
So this leaves us with a final thought about the future that's being built as we speak. We're stepping into a time where we can build smarter, more sustainably, and more efficiently than ever before. So the question really becomes, as this all comes online, what kind of world are we going to choose to create?